have some PET G Natural from Green Gate 3D. I've never heard of these guys. It's natural color PET G. I've had a lot of success printing with PET G, so this should be a really fun one. Let's talk about the specifics on the package. The hot end temperature is 205 to 245, which is an average temperature range for your PET Gs. Bed temperature is room to 90. I've had success with both heated beds and non-heated beds. Speed is none or low, which usually means they don't have a recommended speed, but obviously low since this is a natural. This might be fun to print out some clear stuff. Cooling 25 to 80 millimeters. I think they have that reversed on here. The cooling none to low and the speed 25 to 80 millimeters per second, and then under other it says none. So let me read you the information about this and then I'll show you the filament. It's a USA made PET G from 100% recycled filaments. Everything we extrude in top filament is from recycled plastics and exclusively made in the USA. Even the spools and pigments are American. Interesting. Our PET G prints are lower temperature than virgin resin, offering more users the chance to enjoy our filament. Our clarity is unmatched. We offer precision tolerance and generous flexibility. Recycle the world's plastic one filament at a time. Interesting. So greengate3d.com. This is their PET G. Let me cover up that QR code so you guys can see the filament, or the front of the package, I should say. And of course it is natural, so you'll just be able to see it. It is a nice clear color, so it's a very, very good natural. So there's our second PET G Natural from Green Gate 3D. Now when I usually print with PET G, I'm usually using a heated bed because that's really the best way to get a good layer adhesion and are on the first layer and make sure the prints or the parts don't warp at the end of the print. But I had the sanded acrylic. I've used PET G before to print stuff with on the sanded acrylic. I've used PET G on the sanded acrylic before, so I knew I should probably have some success. So let's start out with the CaliCat because I had success, so I'm pretty happy about that. Here's the CaliCat printed out. It's going to be so hard to see because it's in natural. And the reason why it's in natural is because I'll read this and I'll remind you from earlier in the video, I did mention this, that everything we extrude, the filament is from recycled scrap plastic and exclusively made in the USA. So even the pellets and the spool holders themselves, the spools, they're actually made here in the US and out of virgin plastic, it says, I think too. But all of this is recycled PLA. I don't know why I'm holding this. All of this is recycled PLA, 100% recycled, or recycled PET G, excuse me. Everything in here is recycled PET G from scrap plastics. So it's in natural. It's hard to see, but the CaliCat actually turned out really, really good. There's some minor stringing between the tail and the body, but it's something that's negligible with a small temperature adjustment, not too small, or not too big, I should say. And I think the CaliCat turned out really good. I did have to really look at it to make sure it turned out really nice because it's in natural. Now I do see just a little bit of meltiness near the top, on the top layers. It's really tough to see on there. The brim turned out great. The extrusion width looked really clean and evenly distributed along the brim itself. So that was a good sign. The tail seems like it's pretty strong. I don't want to break it. Broke a part on camera earlier, or two parts on camera earlier. We have other ones here we can break. But the CaliCat actually turned out really nice. I'm super happy with it. Onto the rose twist face. So again, if you follow me on social media, you've seen this, and here it is in the video. And I can tell you, upon close inspection of it, it still looks just as good as it does on camera. Now, the camera's probably not going to do a justification because, it's just, the filament itself is being natural. It's really tough to see the detail. It's really tough to see the print quality unless I was to throw like a coat of paint on it or something like that. But looking at the rose twist face, I really love the way this looks. It's kind of shiny and sparkly in some directions of the light, and others it really does remind me of a drinking or a water bottle. And I'm curious if there's a way to make this clear. And I've seen some methods of putting isopropyl or IPA in a PET G print and rinsing out the inside, and for some reason there's a chemical reaction. I think it's PET G, but that would be really cool, is to be able to take this stuff and actually make it clear. So if you know how to do that, leave it down in the comments and let me know. But this print turned out great, the rose twist face. So off to the Matter Hackers Carabiner. And again, this print turned out awesome. I didn't see any problems with it. There's a little bit of stringing here at the opening, but it's pretty nominal. Okay, we skipped a whole part here about what temperature I'm printing this at. The temperature range is 205 to 245. I printed these out at 230 degrees on the sanded acrylic bed. So printed them out at 0.24 millimeter layer height at 40 millimeters per second. I slowed it down a little bit just to give it a chance, because again, I was worried about bed adhesion and other issues with the PETG printing in long distance. The only print that takes longer than all of these is the Prusa part, and we'll talk about that because we had a successful print there. But the Matter Hackers Carabiner turned out great. I'm super happy with the way this looks. It's a super clean edges on it. I know it's tough to see, but the Matter Hackers M at just the right angle. Let's see if I can show you guys in the close-up camera. The Matter Hackers M looks really nice. The top layer is super clean. It's kind of hard to see, but you can actually see through and see what the infill looks like on some angles. And that looks really good, which is a bonus. Normally you don't get to see how your infill looks on a print. But the actual base of the carabiner turned out really nice. I'm super happy with the way that looks. And the pin or latch part, it turned out really nice, and it's actually somewhat flexible. So I'm curious, we're going to put it together here in a second, if this is got the same layer adhesion issues as the Pro PLA, since I did run these out at a higher temperature. I'm hoping it doesn't. But that print turned out really clean. That part turned out really clean. There was no problems whatsoever. It stuck to the bed because, again, this is two parts sitting on the same build plate or in the same model. So you just printed it as one piece. And it turned out great. I'm super happy with the way this looks. There was no problems, no blobs, no globs, no bad layer adhesion of any kind. So I knew we were going to have successful prints, and I definitely would be ready to move on to the printer part. But before we take a look at that, let's go ahead and assemble this. Again, I should have this down pat. I don't know why it takes me so long to do it, but let's go ahead and jam these guys together. We put that in first, and then we slide it all together like that. And that puts it together perfectly. Boom, we have it. Now, that part seems pretty strong. So let's give it the test. It's not gonna break. So recycled PETG, super, super strong. Very happy with that test. So that was a good strength test because we were able to break the layer adhesion on the latch on this one, but not on this recycled PETG. So that really gives you a good idea of strength. I'm not the strongest person in the world, but I wasn't able to break this and I was able to break that. So this is some really strong filament. I'm definitely going to use this for other stuff. So I'm glad I did that strength test after I already printed this part. This is the Prusa part again. Again, this is added now to our testing. I can feel it. When I took it off the print bed, there was actually no warping. I mean, it is super, super flat. Let me put that there in the close-up camera. It was super flat. I didn't have any problems at all. We're still printing at 230 degrees. I did have the cooling on 30% or 20%. Sorry, we had the cooling on at 40% in the beginning of the prints, and then I realized it says none or low here on the package. So I dropped it down to 20% for the carabiner and for the Prusa part. So this print looks really good. There is a little bit of weirdness going on because these parts have some semi-full bridge or semi-bridging going on along the edges for a recessed nut or bolt, I believe. I'm not sure. Again, I don't have a Prusa. But I like the uniqueness of this part because it has a couple of screw holes or bolt holes, and it has a very interestingly designed area of the print here that has a thin wall, and then there's a recessed area, and of course there's 3 more bolt holes on the back in a vertical panel going up, which gives you a good idea of how well it does completing those little holes. So overall, I thought this was a good idea, and again, if you saw it on the close-up camera, you can see that it looks great, and I had no problems with printing this at 230 degrees. So let's go ahead and give it a little bit of a bend and see if I can snap off the support arm or support bar here. That's probably the weakest part, I'm guessing. So let's go ahead and give it a shot. Oh, no, I did break it in the middle though. So there is the weakness right there. Make sure I didn't cut myself. There is the weakness in that print. So I might actually have to move this up to 245 if I was to use this for any kind of machine part, because we certainly don't want that kind of breakage. Now it broke past, let's see if I can show you guys on camera where it did break. So it broke below that area I was just commenting that I thought was very interesting, and along the top part here where the print finishes up and going straight up, because I printed this with the bottom part here. I'm sorry, this is the bottom part. So the layers are going this way instead of this way. So it didn't really break near one of the screw holes, so I don't think that was a weak part. I think it was probably just some layer adhesion issues. So anyway, good test to see. This seems pretty strong with the layer going in that same direction, going this way on the carabiner, but the strength for this lies in this part as well too, and the way this is set up, so that adds strength the way that's set up. So this I definitely would think about increasing the temperature should I use this filament for printer parts of any kind. But in general, this 100% recycled PETG printed on the sanded acrylic at 230 degrees gave us some excellent results as far as printability and quality. The strength, in my opinion, I think it's pretty strong. I wasn't able to break this, but I was able to snap this with a lot of effort. So that may have been enough to make sure that it is still strong, and I'm just strong enough to break this. But either way, I would definitely increase the temperature if I was going to use it for any kind of printer part. But any kind of other prints in general, I think you're safe around 230, and you can print it on the sanded acrylic or whatever smooth surface if you don't have a heated bed, which a lot of low-budget printers don't have a heated bed on them. They have some sort of textured surface on them for bed adhesion help assistance. So overall, I think the PETG Natural printed out really great.